So we're now going to start the divisibility proof. I said disability proof. No, it's clearly divisibility. I can't say the word. So divisibility proofs can come in two forms. They are either exponential or linear form. We're going to start with an exponential, and this is the base case exponential divisibility proof. So prove by induction that a to the power of n minus 1 is divisible by a minus 1 for all a greater than or equal to 2 and n greater than or equal to 2. So we're going to start, obviously we want the base case, so n greater than or equal to 2, so we'll say n equals 2. So we want a squared minus 1 to equal some multiple of a minus 1. Now if we do a little bit of work here, a squared minus 1 is a plus 1 times a minus 1, which is k times a minus 1. So since both of them share this common factor of a minus 1, therefore true for n equals 2. Perfect. Now, we're going to start with n equals k for k greater than or equal to 2. We're going to have a to the power of k minus 1 is going to be some multiple p times a minus 1. Which we assume. Now, we want to prove it. So how we tend to work this is we want a to the power of k to equal something. So we're going to take from 2, we're going to have a to the power of k equals 1 plus p times a minus 1. Now if we sub k plus 1 into here, we get a to the power of k plus 1 minus 1 is some multiple q times a minus 1. So we're going to expand this using powers, so a times a to the power of k minus 1 is q times a minus 1. So a to the power of k we're going to put in here, so we'll have a times 1 plus p times a minus 1 minus 1 is q times a minus 1. Okay, so we're going to do a bit of expanding here. We'll have a plus, actually I'll expand the inner bracket first. So I'll have a times 1 plus pa minus p minus 1 equals qa minus q. So we're going to have a plus pa squared minus pa minus 1 equals qa minus q. So we want to show that it's a multiple of a minus 1. So actually, if we take this step back, if we just multiply in with the a minus 1s, I think that works. So a plus ap lots of a minus 1 equals q times a minus 1. Okay, so we have, if we actually group these together, so if we have this a minus 1, there we go, we're going to have an a minus 1 plus ap times a minus 1 is q times a minus 1. So look, we have an a minus 1 here, a minus 1 with a scale factor in front of them. So we're just going to have a minus 1 times ap plus 1 is q times a minus 1. Again, sharing this a minus 1 common factor. Therefore, multiples of a minus 1. So therefore, true for n equals 2, and when assumed true for n equals k greater than or equal to 2, proved true for n equals k plus 1, therefore true for all n greater than or equal to 2 and a greater than or equal to 2. I do apologize for the small mistake in the middle, but that is the proof that all numbers in that form are divisible by 1 less than the base.